Okay, so sorry about that. It's because I used the free Screen-O-Matic online and can only record 15 minutes at a time. So this is part 2 of the 30 filters for image processing, and in HC3 and 4, and I believe we were at color depth. Let me check. Yep, increase, decrease color depth. So let's see, we set the colors. We use the formula for changing the color depth, where we take R plus value divided by 2 minus R plus value divided by 2. And then we say that if the new R, which is this one, is less than 0, the new R is 0. If the new R larger than 255, it's set to 255. And we use that for green, and we use it for blue, and then we output the new R, green and blue. Where did I set? Yeah, here I set the value to 1, and then we have the arrow keys. We have the string which shows the value and the arrow keys. And that was it. Let's see the filter. Increasing, decreasing. Looks fine. Next one, hue shift. We shift the colors. So in this case, we made it so it's just this, the hue shift. We have the output, the input of blue becomes red, the input of red becomes green, the input of green becomes blue. Let's see, I think I had some green just before. I have some red. This is blue, but the red becomes green, green becomes blue, blue becomes red. Saturation change. And the add saturation, we have, let's see, we make an integer called add saturation and it's set to -50. We make the colors red, green, blue, and we have an if statement saying that the add saturation, if the add saturation is larger than 0 and R is smaller than 255 minus the add saturation is added to red. Or else, if add saturation is larger than 0, red is 255. And we have another if statement stating that the saturation is smaller than 0 and red is larger than minus saturation. Saturation is added to red. Else, if the add saturation is smaller than 0, red is 0. And we have the output red, green, blue. Change. That gets a little darker. I think it's a little greener. It's the saturation change. We have the sepia, which is gonna make everything a little brown, old school. Make 3 integers for sepia red, green and blue, and their colors. Then we make red, green, blue down here, and we output red plus sepia divided by 2, red plus sepia green divided by 2. Well, the red becomes this, green becomes here, blue becomes here, and that should make it a little brown, as you can see. Fairly easy. The pastel, which is gonna make everything a little more green, red and blue. It should. This is make 9 integers holding the pastel colors, and we make red, green, blue. We say if red is larger than green and red is larger than blue, the pixel becomes, for the red it becomes red plus pastel red divided by 2. For green it becomes green plus pastel red divided by 2. Oh, sorry, pastel red green, and B becomes, and then we have the same for green and we have the same for blue. Then we output the red, green, and blue. Still have something that worked really well. Maybe the dark's frisbee. Yeah, you can see a change in this one. It becomes pastel. The red color tracking, which is gonna make everything black except for the red, which is gonna be white. And we make the colors as always, and we have an if statement saying that if red is larger than green 80 and red is larger than blue 80, then the red becomes white. If there's no red, if there's more green and blue than red, then the red is 0, which is black. The Coke. You can see it works. Then we have the Sobel edge tracking, the kernel edge tracking. Here we have Sobel 3x3 edge. We set the kernel to be Sobel. And then down here we add the kernel. And then we output the sum, which is the sum of pixels and formula for the kernel. That should give us a good edge tracking. You can see on the phone here, you can only see the edges. That works. Then we have the privet, which is pretty much the same. It looks the same. Code is not much different. The kernel is a little different. We only have -1s, 0 and 1s. than that. It's pretty much the same. Also looks the same. Not really any difference. Dilation. And we have the dilation. I can show it first. The first picture is just a normal, second is the bitmap, and then we have the dilation of the bitmap. We declare the red, green and blue, and then we use our red for the dilation. This is actually for the bitmap picture. All red becomes white if it's dominant in the pixel, and else it becomes black. And what we have the dilation, what the dilation really does. It says here, if the sum, it takes the pixel in a 7x7, and if the center pixel is white, all of them becomes white. If it's black, all of them becomes black. You can see it here. And we have the erosion, almost the same. Same here. And then we say if the sum is equal to 9, the output of the erosion becomes 255. If not, it becomes black. Looks almost the same. But instead of only working with the center pixel, and then it checks all the pixels in a 3x3. So like if the center pixel is is white and the rest is around them is not white, then it makes the entire thing black. Or if the whole neighborhood is white, also the center pixel, then it makes it all white. So it becomes more black than white compared to the dilation. We have opening filter. And the difference between the opening and closing is really whether the erosion or the dilation comes first. In the opening, the erosion comes first, therefore it's an opening filter. That's what it looks like. Closing filter, it's just opposite. A little more white. As you can see, the dilation comes first, then the erosion.